This podcast is for informational and educational purposes only. It is not medical advice, and it is not a substitute for professional medical care. Always consult your healthcare provider before making any changes to your health routine, treatments, or supplements. Let's dive into the fascinating world of neurotensin peptides. Neurotensin is a naturally occurring neuropeptide in the human body that was first discovered in the early 1970s. It functions as both a neurotransmitter and a neuromodulator, meaning it can send signals directly or adjust how other neurotransmitters work. This dual role makes it particularly interesting when it comes to understanding mood, energy, metabolism, and even pain regulation. At its core, neurotensin has three main areas of influence. First, it interacts with the dopaminergic system. Dopamine is the chemical of motivation, reward, and focus. Neurotensin helps regulate dopamine signaling, which means it has an indirect effect on mood, energy, and even addictive behaviors. Second, neurotensin affects the gastrointestinal tract, where it influences digestion, gut motility, and appetite regulation. Third, it is deeply tied to the stress response, interacting with cortisol and other stress hormones. Let's start with neurotensin's role in the brain. Research has shown that neurotensin levels increase during stress and may help calm overactive dopamine systems. This has been linked to antipsychotic-like effects, which is why neurotensin analogs are being studied as potential treatments for schizophrenia. The peptide appears to help balance dopamine activity, preventing both overexcitation and underfunctioning. This balancing act is critical for mental health, focus, and emotional regulation. Another interesting point about neurotensin is its connection to thermoregulation. Studies have shown that injections of neurotensin can reduce body temperature. This hypothermic effect is unique and has been used in animal research to understand brain temperature regulation and its link to metabolism. While we don't yet fully understand what this means for human health, it hints that neurotensin may be involved in fine-tuning metabolic rate and energy expenditure. Now, let's shift to appetite and weight regulation. Neurotensin is released in the small intestine after eating, particularly in response to fat intake. It works with other peptides like cholecystokinin to slow gastric emptying and promote satiety. In simple terms, neurotensin helps you feel fuller after a meal and may prevent overeating. In fact, some studies suggest that higher circulating levels of neurotensin after meals are associated with better appetite control. On the flip side, dysregulation of neurotensin signaling has been linked with obesity and metabolic disorders. This makes neurotensin a potential therapeutic target for weight management. In addition to appetite, neurotensin is also being studied for its role in inflammation and pain. It has demonstrated analgesic effects in animal models, acting somewhat like natural opioids but through different mechanisms. By binding to neurotensin receptors in the brain and spinal cord, it reduces pain perception. This opens the door for possible development of non-opioid pain therapies that harness the neurotensin system. One of the most fascinating aspects of neurotensin is its relationship with mental health. Beyond schizophrenia, researchers are exploring how it might influence anxiety and depression. Since neurotensin interacts with both dopamine and serotonin systems, it could theoretically improve mood regulation. Some animal studies show antidepressant-like effects, though human research is still limited. There's also evidence that neurotensin can influence learning and memory, again by interacting with dopamine circuits in the brain. Let's take a closer look at neurotensin receptors. There are three main types, known as NTS1, NTS2, and NTS3. Each one plays a slightly different role. NTS1 is primarily linked with dopamine regulation and antipsychotic effects. NTS2 is more connected to pain modulation and body temperature regulation. NTS3, sometimes called sortilin, has roles in cell growth, survival, and neuroprotection. Understanding these receptors is key to designing drugs or therapeutic peptides that selectively target specific effects of neurotensin without unwanted side effects. One challenge with using neurotensin therapeutically is that the peptide itself has a short half-life in the body. It is rapidly broken down by enzymes, making it impractical for long-lasting effects. That's why researchers have developed neurotensin analogs, synthetic versions that are more stable and can last longer in circulation. Some of these analogs are in preclinical or early clinical testing, showing potential for conditions ranging from schizophrenia to chronic pain. Another area where neurotensin is getting attention is neurodegeneration. Because it has neuroprotective properties, scientists are looking into whether it could help in conditions like Parkinson's or Alzheimer's disease. In Parkinson's, where dopamine-producing neurons are lost, neurotensin could help regulate dopamine receptor sensitivity and protect remaining neurons. In Alzheimer's, its antioxidant and cell survival effects may provide some degree of protection against neuroinflammation. It's also worth mentioning that neurotensin may play a role in cancer biology. Elevated neurotensin levels and receptor activity have been found in certain cancers, particularly colorectal, pancreatic, and prostate cancers. In these cases, neurotensin may actually promote tumor growth and metastasis. This has led to research into neurotensin receptor antagonists as possible anti-cancer therapies. So, depending on the context, neurotensin can be either beneficial or harmful, which is why it's such a complex target. From a practical standpoint, what does all this mean for someone interested in peptides today? Currently, neurotensin peptides are not widely available for clinical use. Most of the work is still happening in research labs. However, understanding its roles can help guide future therapies in mental health, pain management, obesity, and neurodegenerative disease. For biohackers or peptide enthusiasts, it's important to remember that this is an emerging area with more unknowns than knowns. Let's take a moment to think about how neurotensin interacts with lifestyle factors. Stress, diet, and sleep can all influence peptide systems. For example, since neurotensin is released in response to fat intake, different macronutrient profiles could shift its activity. Stress can upregulate neurotensin in the brain, perhaps as a compensatory calming mechanism. And because it interacts with dopamine, lifestyle factors that affect dopamine, like exercise, novelty, and sleep, may indirectly influence neurotensin as well. Another fascinating area is how neurotensin interacts with other peptides you may already know about, like GLP-1, ghrelin, and leptin. Together, these form a network that tightly regulates appetite, metabolism, and energy balance. Neurotensin works alongside GLP-1 to slow gastric emptying, while ghrelin has the opposite effect, stimulating hunger. This push and pull between different peptides highlights the complexity of appetite regulation. It's rarely just one molecule at play, but rather a symphony of signals working in harmony, or sometimes disharmony. Let's circle back to pain for a moment. The opioid crisis has created an urgent need for alternative pain therapies. Neurotensin-based treatments could represent a breakthrough, providing pain relief without the risk of addiction. By targeting NTS2 receptors, researchers hope to achieve analgesia without the dopamine reward pathway activation that fuels opioid misuse. Early animal studies are promising, but more human trials are needed before we can know for sure. There's also a growing interest in neurotensin's cardiovascular effects. Some research suggests it may help regulate blood pressure and vascular tone. However, other studies link high neurotensin levels to increased cardiovascular risk, including heart attack and stroke. Again, this shows the double-edged nature of this peptide. Context matters. The right balance may be beneficial, while too much or too little could cause problems. If you step back and look at the bigger picture, neurotensin sits at the crossroads of brain, gut, and metabolism. It connects mental health to physical health, appetite to weight, and stress to resilience. This makes it a fascinating example of how small peptides can have broad, systemic effects. To summarize, neurotensin is a peptide with diverse roles in the body. It helps regulate dopamine, influences stress and mood, affects appetite and digestion, modulates pain, and may have roles in neuroprotection and cancer. While it is not yet a mainstream therapy, it holds promise in multiple areas of medicine. The challenge will be harnessing its positive effects while avoiding unintended consequences. This podcast is for informational and educational purposes only. It is not medical advice, and it is not a substitute for professional medical care. Always consult your healthcare provider before making any changes to your health routine, treatments, or supplements. Thanks for listening, keep learning, and stay curious.